Hello, my little lads. I know you thought you saw the last of me, but I have a few more lessons to teach you. I'm just going to teach them through the camera. So this says 6-5, solving linear equations. This is lesson 4-4. So it is the fourth lesson of chapter 4. We'll have one more after this and then some review. So it says solving linear inequalities. So what we're going to be doing is we were solving systems of equations, looking at where two lines cross on a graph. This is where we're going to be looking at how linear inequalities look at a graph. So let's just kind of dive into some definitions, talk about what it is, and then and then you'll see exactly what I'm talking about. I'm going to move this because I don't like the way it looks when I write. So, all right. So remember solving inequalities. So this is going back to last chapter. Graph this inequality on the number line. So in order to graph this on the number line, what did we do? What did we have to do to graph it? Yeah, we had to get x by itself so we know what number x is greater than or less than. So let's go ahead and start with that. So we're going to add 1 to both sides. Plus 1 plus 1. That gives us negative 2x is less than 4. Now we're going to divide by negative 2 on both sides. What do we do when we divide an inequality by a negative? Yeah, we got to flip that sign. So it's going to be x is greater than, not less than. And 4 divided by negative 2 is negative 2. So graphing that on the number line, we can have a negative 3, negative 2, negative 1. All right, so we have just x greater than negative 2. So is that going to be an open or closed circle? Yeah, it's going to be open because there's no equal to sign like that. So it's going to be an open circle. I'm going to grab a pink at negative 2. And it says greater than, so we're going to go in the greater than direction. All righty. Now we're going to do the same thing with inequalities that have x and y. So when we're defining a linear inequality, we are talking about an inequality with a linear function. So a linear function which involves an inequality. And all I mean by inequality is just that, like, greater than, less than, greater than or equal to, less than or equal to. So it just involves that instead of an equal sign. A solution to a linear inequality is going to be involving two variables, x and y. So any x comma y that makes the inequality true. This means that if you plugged in any x or y to the function, that you would come out with a true statement. And you'll be able to see them on the graph as well once we get to the graphing part. All right, tell whether the ordered pair is a solution to the inequality. So what did we do to figure out whether an ordered pair was a solution to our system of equations? Right, we plugged it in. So let's go ahead and do that same process. So this is our x, this is our y, and then this is our function. Sorry. All right, so plugging in our 3 for our y and our 7 for our x, we have 3 is less than 2 times 7 plus 3. All right, 2 times 7 is going to be 14, so 3 is less than 14 plus 3. 3 is less than 14 plus 3 is 14, 15, 16, 17. 17. Is 3 less than 17? Yes. So this is a solution to that inequality. All right, go ahead and try 2 and 3 on your own, so you can pause the video here. All right, you should have both this 4, -1 and this 1, 1 done already, and you're just checking your work at this point. So let's start off with this 4, -1. We have x, y. Plugging in -1 for y, we get -1 is less than 2 times plugging in 4 for x plus 3. -1 is less than 2 times 4 is 8 plus 3. Negative 1 is less than 8 plus 3. 8, 9, 10, 11. Is negative 1 less than 11? Yes, so this is true, which means it is a solution. So both of these ordered pairs, 7, 3, and 4, negative 1, are solutions to the equation presented. Now going to this last one that you should have already done. X, Y, Plugging in 1 for y, we get 1 is less than. Plugging in 1 for x as well. 2 times 1 plus 3. 2 times 1 is 2. So 1 is less than 2 plus 3. 1 is less than 2 plus 3 is 5. That is a true statement, which means, yes, we do have a solution to the equation. Perfect. All right. So now we know how to check if an ordered pair is a solution. Anytime you're presented with a problem that looks like this, you would be able to check it. Now, examples of graphs of linear inequalities. So what we're going to do is we are going to graph this just like it was a function that looked like y equals mx plus b. So whatever is attached to the x is going to be our slope. Whatever is not attached to an x but still not next to the y is going to be our y-intercept. So we're gonna graph these as if they are in slope-intercept form, which they are. They just have the only difference is they have an inequality sign rather than an equal sign. So if you had that equal sign, it would just look like the ones that we are used to graphing. So we have a slope of 2 and a y-intercept of 3. So graphing this, we're going to start off with our y-intercept. So we're going to go to 3 on our graph. 1, 2, 3. We got a point right there. And now let's make some more points. Our slope is 2, which is 2 over 1. So we're going to rise 2, run 1. Rise 2, run 1 will be right there. Rise 2, run 1 will be right there. Make some more dots in the other direction. Go down 2. Since we went down instead of up, we're going to go left 1. Down 2, left 1. Make some more. Down 2, left 1. All right. So now what we need to be careful with is whether our sign is less than and greater than, or if it is less than or equal to and greater than or equal to. So in the past, we had open circles versus closed circles. This time, we're going to have dashed lines versus solid lines, okay? So since this one is just less than, we are going to have a dashed line across here. So what you're going to do is just make a dashed line of sorts like this. And I'm just going to extend it up and down across this. And then we're not quite done. We graphed the line, but it says that y is less than. So if you're looking at your graph, you know that going upwards is positive and going downwards is negative. So if we want to graph less than, we would be looking at anything below this line. So the other thing that you need to be able to do in this is be able to shade. So I'm going to grab a big, and then I'm going to shade. The less than direction is going to be down here because it's in the negative direction, and you're just going to shade all of this. And then this is our inequality graph. So we have that dashed line, shaded, less than. That's how you graph an inequality. Let's do one more together. So we have, whoa, that's so big. All right, go back down to 1. We got our slope of 2, which is 2 over 1. Whoa, 2 over 1. And our y-intercept of 3. Let's go make some points. We start off with our y-intercept, so we're going to go and look at our y-axis, grab 3, 1, 2, 3. Go use our slope of 2, so rise 2, run 1. Rise 2, run 1. Rise 2, run 1. Starting to look real similar to the last one, right? down 2, run 1. Let's just keep making points, and then we can talk about how it's different. So remember on these, we can't just put a line through it. We have to look at the sign. And if you look at this sign, I'm going to change this transparency if it'll let me. We have a sign of less than or equal to. So that is an equal to, which means we're going to have this solid line. So let's go back up to our transparency. And we're going to put a solid line through this. So just draw a solid line to the best of your abilities. It's okay if it's not perfect. We are doing our best, right? Always doing our best. All right. Now reading that sign, is it a less than or a greater than? Good, is a less than. So we are going to shade in the less than direction. So we're looking up and down when we're looking at our less than or greater than. If it is greater than, you are going to shade above that line. So write that down somewhere. Here, we can do a little note over here. So greater than, comma, greater than or equal to, shade above. Less than, comma, less than or equal to, shade below. When y is. There's a good little note for you. I said below and didn't spell below right. There you go. So shade above, shade below. So let's go back to our example. It says less than or equal to, so we are going to shade below. So I'm going to grab this at an 8 again, but change my transparency so it's like a little easier to look at, I think. Oops. Oh gosh. It's really damn finicky right now. So it says less than, so we're going to shade below. And let's talk about the solutions real quick before you do the other two on your own. So that means that any ordered pair that falls in these shaded regions is a solution to this equation. So any ordered pair that in this shaded region is a solution to this equation. So if you went and looked at, just picked a point, say right here, that is 1, -5, is a solution to this equation. I can show you that by plugging this in. So 1, -5, that is our x and our y. So if we plugged in -5 for y, we would have -5 is less than or equal to 2 times 1 for x plus 3. 2 times 1 is 2, so -5 is less than or equal to 2 plus 3. 2 plus 3 is 7, so -5 is less than or equal to 7. So that's true. So any ordered pair that you chose in this shaded region is a solution. The difference between the striped and the solid line is if you chose an ordered pair on the striped line, it would not work. It would not be a solution because it's not equal to. But if you chose an ordered pair on this solid line, it would work because it is equal to. All right, go ahead and do these two on your own. So pause the video here. All right, you should have already done these two right here. So I'm just going to show you the solutions and then we'll move on. So y is greater than 2x plus 3. What do you notice about all these equations? They are the same equation with different signs each time. So let's just go ahead and graph those equations real quick and then we can go from there. So 3 up 2 over 1, up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. All right, we have greater than, which is not an equal to, which means we need to do a dashed line. So dash, 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 dash. Okay. And since it says greater than, Remember, greater than, we're going to shade above. So we're going to go ahead and grab this transparency down to here and shade. Oops, I'm going to change that to a big one. Shade above. Little fun fact, if you chose a point that's not on the graph, so say you chose a point way up here, that would still be a solution. So say it was like negative 12, 37, which would be a point like way up here, like negative 12, 37, not on the graph, but it still would be in the shaded region because these functions go on forever. So anything that is in that region, no matter if it's pictured on the graph or not, could still be a solution. All right, going to our last one on this page. Turn that transparency back up. All right, so plus 3 is right there. And then up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Down 2 over 1. It gets kind of hard to do that just by eyesight without the little grid. All right, so let's look at it. It is a greater than or equal to. So why is greater than or equal to? That equal to tells us it's going to be a what? Right, a solid line. So we're going to just make sure we do a solid line right here. All the way through these points that are like kind of right. Remember, these lines still do go on forever because they are linear. All right, and then greater than or equal to, are we going to be shading above or below? We are going to be shading above because it is a greater than sign. So let's go ahead and change that. And let's shade above. So anything in this shaded region would be a solution. All right, next page, everyone. So some key things to remember for inequalities. I'm going to go change this transparent back to all Gucci and change it back to 1. When there is a less than or greater than, we have a dotted line, which would look like choo, 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 choo. When we have a less than or equal to or greater than or equal to, what's different? We have a solid line, which choo, 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 choo. Sorry for all the sound effects, but whatever. If it is less than or equal to, we will, good catch, shade below. Below. And if it is greater than or equal to, we will shade above. And by below, we mean below the line. And by above, we mean above the line. Any of this region from this line, and any of this region from this line. All right, so all you need in order to graph something to reference is this little section right here. This will help you reference and be able to graph any of these as long as you can remember how to graph a linear equation. Graph the inequalities. Remember to flip the inequality when dividing or multiplying by a negative. So we're going to start off with this one. It's in y equals mx plus b form, which means it's in slope-intercept. So our 3 is our good. That's our slope because it's attached to our x. Everything attached to our x is going to be our slope. And our 4 is our y-intercept. All right. So 4, right there. Our slope is 3, which is the same thing as 3 over 1. So we're going to rise 3, run 1, rise 3, run 1. Opposite direction, rise 3, run 1, rise 3, 1, 2, 3, run 1, rise 1, 2, 3, run 1. All right, that's enough points, I think. Now looking at the sign, we have less than, solid or striped line. Good, it is going to be a striped line. So Remember, it's still a line. You can put those arrows on there. And since it is less than, are we going to shade above or below? Right, we are going to shade below because it is less than. We want to shade in the negative region. So less than is all this area right here. And if you are using pencil and you want to do like a striped pattern like that, that also works. All right, I want you to do this one on your own, and then we can talk about this one real quick, but you can still do it on your own. So 4 minus 3y is greater than 12. That's not in y equals mx plus b form, but you can still solve it to get in that form. So you're going to work with it just like you would an equation with an equal sign. So you're just going to be solving for y, trying to get everything away from y. First, we're going to subtract 4x from both sides, so minus 4x minus 4x. We end up with negative 3y is greater than 12 minus 4x. All right, and now we need to solve for y still, so we're going to divide everything by negative 3. What happened right there? We divided by a negative, so we need to flip the sign. So y is less than 12 over 3 is going to be negative 4 minus negative 4 over negative 3 is a positive, so plus 4 over 3x. So we're in y equals mx plus b form, a little out of order. So our m is what? Yeah, so our m is our 4/3 and our b is our negative 4. Go ahead and pause your video here and go ahead and do these next two, graphing them, and then come back when you're finished. Check your work. All right, so starting off with this one, we have 2/3 as our negative 2/3 as our m and 1 as our b. So 1. We have negative 2/3. So if we rise 2, we're going to run 3 in the negative direction. So 1, 2, 3. Be right there. Rise 2. Run 1, 2, 3. It's really hard to do that without a graph, like the grid lines behind it. Let's keep going. Rise 2. Run 1, 2, 3. Rise 2. Run 1, 2, 3. All right, that's going to be good enough for our points. It is greater than or equal to, so we're going to be a solid or striped line. Good, solid. And since it is greater than, are we going to shade above or below? Perfect. We are going to shade above because we're going to shade in that greater than region. All right, that should be your solution for that one. Now, going into this next one, we have y is less than negative 4 plus 4/3 x. We said that negative 4 was our b, so let's just start with that. So negative 4 is right there. 4/3 x. Rise 4, run 3. So rise 1, 2, 3, 4, run 1, 2, 3. Rise 1, 2, 3, 4, run 1, 2, 3. Rise 1, 2, 3, 4, run 1, 2, 3. If this isn't exact, that is okay. So rise 1, 2, 3, 4, run 1, 2, 3. So that's going to be close enough. Y is less than. Is that going to be solid or striped? Good, striped. So go ahead and make your striped line or dotted line, however you want to say that. As long as it is not a solid line and it is less than, so we are going to go ahead and take that transparency down and make that bigger. Less than, we're shading above or below? Below. So now that we know how to graph them, let's figure out our equation. from a graph. So going into this one, what you are going to look for in your graph is it has these points. These are our x and our y intercepts, x and y intercepts, x and y intercepts. So we can use that. We can grab our b, which is going to be the one that touches our y-axis, and then we can count our slope from point to point. So using that information, our b is going to be equal to 1, 2, 3. And then if we count this, this is going to be up 1, 2, 3. So rise 3, run 1, 2, 3, 4. So rise 3, run 4 is going to be R n. So making the equation, we would normally write y equals 3/4 x plus 3 off of y equals mx plus b, just replacing our m and our b with what the information we grabbed off the graph. But since it's a linear inequality, we need this equal sign to be a less than, greater than. So what direction is it shaded, above or below? Yeah, it's shaded below, which is less than or greater than. It's going to be less than. The last thing we need to look for is if it is a solid or striped line. So this is a solid line, which means is it equal to? Good, it is. So that would be your answer for this one. Go ahead and do the same steps on these other two, finding your m and your b, and then making your equation with your inequality sign. Pause the video here and come back to check your answers. All right, you should have already done these two. This is just you checking your answers. So our b here is equal to -6. If we count our rise over run, we're going to rise 1, 2, 3, 4, 5, 6 in the negative direction. So m equals rise is -6. Run is 1, 2. So run is +2. 6 over 2 reduces to -3. So making y, and I'm going to leave this equal to spot blank, -3x minus 6. All I did was replace our m and our b. And now what is our sign? Are we shaded above or below? We're shaded above the line. So it was going to be greater than or less than. It is going to be greater than. And is it going to be equal to? No, because it's a dotted line, so this is our answer. All right, checking your last one, we got that y-intercept of -2, and that slope is rise 1, 2 in the negative direction. So rise -2, run 1, 2, 3, 4, run 4. That would reduce to -1 over 2. Replacing our m and our b, we got y. We don't know what our sign is yet. I'm going to leave that blank. Is -1/2 x, replacing our m with our m that we found, -2, replacing our b with the b that we found. All right. Is it shaded above or below? Above. So is it greater than or less than? Greater than. Is it a solid or striped line? Solid. Does that mean it's equal to or not equal to? Equal to. So we're going to put that equal to sign, and that is the equation you should have had. All right, so you're done with your notes part. I have a worksheet for you to work on. Go ahead and grab the worksheet now. Start going through those problems, and the solutions are posted on Schoology. Bye, guys.